He can do it. There is no problem. ఆయన చేయొచ్చు కావాలనుకుంటే. No problem. Attend. ఇదే కదా ఫస్ట్ లైన్.
హైట్ చేయాలి. హైట్ చేయాలి.
होता है तो मैसेज होता है
నేను చేస్తాను వదిలేసి అక్కడ నేను వచ్చేసి
గ్రాఫిక్స్ చూడండి, గ్రాఫిక్స్ బాబు సార్ చెక్ చేయమ్మా యూట్యూబ్కి. సమ్ డిస్టర్బెన్స్ ఆన్ ది లైన్. ప్రతి సిస్టంలోనే మైక్రోఫోన్ ఇష్యూ ఉంది అనుకుంటున్నాను.
హెడ్ఫోన్స్ పెట్టేద్దాము.
ఓకే.
Yeah, good afternoon, Professor Amit Prasad, Dr. Suklaji. Very good afternoon.
Good afternoon.
Yes. Shall we start the session?
Yes, please.
We have to start by 4 o'clock.
I think 2 minutes are there. Let's wait for 2 minutes.
Yeah, please. So before that, there is a small announcement. So we have to select 2 best paper out of the 30 in this session. So, as a chair and co-chair, please identify 2 best papers for Springer Award. So each paper we have fixed 6 minutes, so that we will be able to complete within 1 hour 50 minutes.
So Jay, you will be taking the time clock, right? Jay, you are on mute.
Yeah, please unmute. You are not audible. Please check your.
Hello, is it okay?
Yeah.
Yeah.
ఓపెన్లో ఉంది, అందరూ జాయిన్ అవుతున్నారు. 22 మెంబర్స్ ఉన్నారు ఆల్రెడీ.
So is Professor Shripriya here?
Professor Prashant, I will be taking the times. Yeah.
వాళ్ళు కాకుండా పార్టిసిపెంట్స్ కూడా వచ్చేసారు. స్టార్ట్ చేస్తున్నాం.
Sorry, I missed the response.
Yeah, as you said, I will be taking the time
Okay.
for the presentation. Yeah, I will moderate that. That's okay.
Yeah. So is Professor Shripriya here? Shripriya Mukherjee? Not yet.
Sir, actually we have to show on slide before each presentation. అది నా దగ్గర ఉంది. నేను స్క్రీన్ షేర్ చేసి స్లైడ్ చూపిస్తాను, అప్పుడు టేక్ అవుట్ చేసుకుంటారు. నువ్వు లోపల ఉందా?
So, Professor Muthukumar, and we can start probably.
Professor, you are on mute.
Yeah, very good evening, one and all person here. So it's very clear, a great pleasure to start the first technical session.
వాయిస్ వినిపించట్లేదండి వాళ్ళు
We have two eminent people, those who are going to share this session. Professor Amit Prasad from IIT Gandhinagar and Dr. J. Shukla
చేయొచ్చా చేయకూడదా
from Geostatics. Let me briefly introduce Professor Amit Prasad. Dr. Prasad is a professor of civil engineering and dean of research and development at IIT Gandhinagar. He is currently the chairman of IGS Ahmedabad chapter and also member of board of governors SPNIT Surat. He completed his bachelor of engineering degree from IIT Roorkee in the year 1997. After 2 years of consulting experience, he went for the higher studies at Carson University, New York, and then to University of Lesnies, Knoxville. After completing his doctoral studies and 1 year of postdoctoral research, he worked at IIT Kanpur as assistant professor during 2005 to 10, and then moved to IIT Gandhinagar in 2010. So he has been actively involved in academic administration with 6 years as Dean Academic Affairs before the current tenure of Dean R&D at IIT Gandhinagar. With that experience, he was also appointed as officiating director of IIT Gandhinagar during July 2019 to September 2019. His research interests are in constitutive modeling of soils, earthquake geotechnical engineering, and applications of geosynthetics, which includes experimental investigation and numerical modeling. He has done field projects related to hill slopes, excavation, canals, ash dike, bridge foundations, barrage, etc. He has conducted several industrial courses in earthquake engineering, FEM, and geotechnical investigations, which have been quite popular. He is also conducting a faculty development programs for last 6 years under the aegis of Techute scheme of Government of India for engineering colleges country. So with the brief introduction about Professor Amit Prasad, we introduce our co-chair, Dr. J. Kumar Sukla. Dr. J. Kumar Sukla obtained his master's in geotechnical engineering from Maharashtra Jayawarde University of Baroda. Further obtained his PhD from IIT Bombay, and he has served as a geotechnical engineer in various prestigious organizations such as ASER, Tectonic India Private Limited, and L&D. So he is now providing his service as principal engineer at Geodynamics, Baroda. He also worked as a lecturer, Department of Applied Mechanics at SS Engineering College, Government of Gujarat. He is also member of National Executive Committee of IGS, Delhi. So with a few introduction with respect to our chair and co-chair, now I hand over the session to the chair and co-chair. Please take the session. Thank you.
Thank you, Professor Muthukumar. I think it is very nice of you to introduce us to this group. I think this theme is very basic and relevant to any of the person joining this session. What I say to my students is, if you read soil mechanics once, then you have just touched the topic, and every time you read, you understand more and more about it. Same thing goes with research. I think as I think the Times of New York Times once published that once you are done with you can say planetary physics and rocket science, then comes sand. You can say, right? So that was a think very relevant to what we are going to have this session on diversity and the complications and the love of soil mechanics for this theme, soil behavior and characterization. With that, I think we are supposed to start with the theme lecture by Mr. Shubhapriya. I'm not sure if she has joined. Probably she's delayed. Do we have any information, Dr. Muthukaran? No.
Let me check with the organizer. Yeah, please.
Okay. So Jay, shall we start with presentations for the time being? Maybe after a couple of presentations we can come back. You are on mute.
Yes, we can start because losing time is not that's a good thing. So we can start.
Okay. So is Akila M and group is here? Dr. Akila?
Hello, is it audible?
Yes, yes. Not yet. I think if you want to start your presentation, please go ahead.
Okay,
You can share your screen.
Okay, sir. I will.
అవును దీంట్లో ప్రెజెంటేషన్ తెచ్చాను దీంట్లో
అంతే
I hope
Then she started presentation.
is the screen visible?
Next slide.
Yes.
Okay, can I proceed?
Yes, please go ahead.
Okay, thank you, sir. Good evening, all. Myself, Dr. Akila, Assistant Professor, SCMS School of Engineering and Technology, Ernakulam, Kerala. I am here to present just a brief topic on the effect of plasticity of fines on the properties of uniformly graded fine sand. These are the contents of my presentation. Now, moving on to the introduction, even if we researchers separate the soil based on the particle size, we all know that in the field they exist in combination. So it is very essential to know, to get an idea regarding the effect of fine content and plasticity of those fines on the properties of soil. Because there are many studies which have concentrated on this effect of fines on the soil properties, but very few concentrate on the plasticity of those fines. Due to the time limitation, I'm not going into the literature review part. I'm directly going into the study which we have done. For the present study, in order to get an idea regarding the effect of PI plastic index of fines and amount of fines, to get a control over the properties of the soil, it was decided to prepare the soil samples in the laboratory itself. So for that, we have collected 4 different type of soil samples, that is fine sand from Cherala region of Alappuzha district in Kerala. Then the curry powder was collected from a local quarry in Calicut, and it was sieved through 75 micron sieve, and the fine parts were used. Kalinite clay was also prepared from Calicut, and natural clay was collected from Padirankavu, Calicut district, Kerala, and it was wet sieved, and the fine parts, that is which is passing through the 75 micron sieve, was used for the present study. And mixing these 4 components, 16 samples were prepared by changing the fines contents from 10 to 40%, that is 10, 20, 30, and 40, and by varying the plastic index from 0, 5, 10, and 50. So these are the photographs of those samples, and the table shows the property of the fine sand alone, to which the silt and clays were added at different fines content, and further, the properties were tested. All the index properties as well as some of the engineering properties were tested to know what is the influence of the PI of the fines on these properties. Now, going into the results of index properties, initially specific gravity was determined using the pyknometer method. And even if the graph shows some difference in the values, regarding the percentage difference, it is found that the difference is for up to 40% with a PA value of 50 to the fine set. The difference in the specific gravity is only less than 5%. So we can say that the fines content and the PA value doesn't have much significant effect on the specific gravity. Now, the next property which was tested was void ratio. So to find out the void ratio, maximum and minimum densities were found initially. The maximum density was found using the vibratory table, and the minimum density was found by filling the sample loosely in the CBR mold and measuring the volume and weight. From that, using the specific gravity, maximum void ratio and minimum void ratio were determined. And it is being plotted with respect to fine content and plasticity index. And it is, from the result, it is clear that the fines content has, and even the plasticity index has a significant effect on the maximum void ratio as well as the minimum void ratio. There was up to 30 to 40, sorry, 10 to 15% difference in the values of maximum void ratio when we add fines content up to a PI of 15. After that, to get an idea regarding the plastic particle size characteristics, combined sieve analysis as well as the hydrometer analysis were done, and the particle size distribution curves were drawn, and from which D50 was found. Any issues are there? Am I audible? Because some message.
No problem, no problem.
Okay, thank you. And D50 was found. And regarding the plasticity index, from the second figure, it will be clear that if at a particular point, PI doesn't have much significant effect. Even if the fine content is having a significant effect on the D50 value, doesn't have a significant. Next, to find out the effect on the direct shear tests were done both densest possible condition as well as the loosest state, so that maximum 5 and minimum 5. Observation shows that as the PA value of the fines increases when tested at a particular fines, maximum I value decreases considerably. There was about a 50% reduction in the phi value when tested with PI of 15. But when we are comparing at a particular plasticity index value, the increase of the fines content doesn't have a much effect on the angle of internal friction. Next, consolidation tests were done to find out what is the effect on CC values on this regarding this variation of PI and fines content. There also, if we are comparing the result at particular fines content, as the PI increases, the CC value also increased almost about 5 times. The maximum increase was up to 5 times. But when we are comparing the results at a particular fines content, the difference in the CC values were not that significant. So after that, fractional was done both under static as well as cyclic condition. In the case of static coaxial testing, the samples were tested at 100 kPa effective pressure. And if you are comparing the result, you can, from the table, it is clear that at a particular fines content, say at 10% fines content, when the PA is increased from 0 to 50, the maximum deviated stress values are increasing, and the pore pressure ratio at 20% strain is going on decreasing. Then the effect of this fines content and plasticity index was studied on the liquefaction properties as well, but these results are already published. And for that, the cyclic coaxial test has been conducted at 3 different CSRs on all the soils. and liquefaction resistance curves were drawn, from which the CSR corresponding to 20 number of cycles were found, and this graph is being plotted. You can see that when the plastic index is rise from 0 to 5, there is a slight decrease in the CSR corresponding to 20 cycles, but afterwards the CSR value increases, which shows that initially there is a decrease in the liquefaction resistance, but afterwards the liquefaction resistance increases as the PI is increasing. So coming to the summary and conclusion, the effect of fines content and PI was the study on the effect of PI and fines content was conducted on the controlled samples prepared in the laboratory, and it has been found that the effect of Asti index on the specific gravity and D50 values are insignificant, but it has a significant effect on the angle of internal CC values, pore pressure ratios, and liquefaction resistance of the sandy soils tested. So these all are the references. Thank you.
Thank you, Dr. Akila. We can take one question if there is, otherwise we move on. I guess there is no question at the moment. Just one question: which test did you do for the liquefaction assessments?
The cyclic triaxial.
At what confinement pressure range?
Confining pressure was fixed as 100 kPa, sir.
100 kPa. So
Okay.
just one confinement or different confinements?
No, sir, only one confinement.
Okay. Thank you. Thank you so much.
Thank you, sir.
So I see Dr. Shivapriya is here.
Yeah, he has joined.
Yeah.
Shall we continue with the theme load?
Yeah, we can bring that thing.
Yes, I have joined. Good afternoon.
Good afternoon, sir. So it is pleasure to have you, sir. I think Professor Shivapriya is from Jadavpur University, and he has a lot of experience with different, you can say, soil characteristics aspects he has looked at from research perspective. So I would like to invite him for this theme. Topic is study on improvement of CBR characteristics of soil subgrade. So kindly share your presentation and enlighten us with your work.
Thank you. So I am presenting.
Jay, you can mute your mic.
I don't know why it is not coming. I have clicked at present now, but I don't know why it is not coming.
So in the present now, you can do entire screen if you want.
So please select the present now mode.
Yes, I have selected it.
Yeah, in that there will be 3 icons. You can see that. Either you can select that entire
Yes.
window you can select.
Yes.
Yeah, please.
So I have shared it.
Yeah, please.
Can I see my screen?
Yeah, it's coming.
Yeah, that's fine. Yeah.
Yeah, very good.
Now you can select your file and open. Yes.
Yes, it is opening, I think.
Yeah, it is coming.
So, very good afternoon. Thank you all, and thanks to the organizer for inviting me to deliver this theme lecture. One thing is disturbing.
Sorry for the interruption. Please make it presentation mode, sir.
Okay. That I am doing.
Yeah, please.
This thing is disturbing actually.
If you keep it in presentation mode, this won't come.
Okay. Slideshow.
Yeah.
Or I can just put F5 also. It is not working, however, I don't know why.
You just select that particular Gmail account. Otherwise, it won't allow you to do that.
Okay.
Yes.
I have that also I have selected, but it is not going anyway.
Otherwise, you just track down and keep it in the downwards and put it in the slideshow view.
From beginning I have put, so now it has come.
That's okay. Yeah, that's it.
Yeah, fine.
Very sorry for giving you trouble. So thanks to Mr. Chairman, Co-Chairman, the coordinator, and also I thank the organizers of IGS for inviting me to deliver this lecture. So very good afternoon. So I am starting my lecture. This is on soil behavior and characterization, a study of improvement of severe characteristics of soil substrate. Now, this is the overview of the presentation. So, first of all, the introduction. Now, soil behavior is complex due to the fact that soil is a three-phase system and it consists of soil, water and air. Further, its behavior depends on the age of deposition and its geological history and stress history. In respect of geotechnical engineering, soil characterization involves finding grain size and Atterberg limits, that is index properties, to understand its contents of sand, silt and clay size particles and plasticity, as these basic factors determine the behavior of soil in the field. Then comes shear strength and compressibility. Shear strength indicates the endurance of stress of the soil and compressibility is important, particularly in case of clay soil, uh, which is which becomes important at the time of consolidation when the soil is undergoing consolidation. Now, when soil is required as a material, say for construction of a subgrade or an embankment, then the compaction properties are to be considered. So naturally, OMC and MDD, and that is for the standard Proctor compaction or modified Proctor compaction, as may be the case. So now, therefore, it is understood that prediction of ground characterization need estimation of relevant soil properties done by both in situ and laboratory tests and establishment of correlation between field and laboratory tests. And it is also necessary for a qualitative checking of soil characteristics by the correlation between the two, such as we do it, say, with n value, the cohesion and angle of internal friction. Sometimes we check by Tarzagi's uh, correlation. Then it may be required to build defined types of structures, say for hydel power plant or other projects. There are different structures with different depth of completions and different shapes. So all these things are to be addressed properly, of course, including the seismic effect, considering the seismic effect, as has been indicated in this conference today by Professor Sitaram and also by Professor Dipankar Chaudhary. Now, in order to study the feasibility and proper planning of a project, along with topographical surveying, geotechnical site characterization is necessary. This involves geotechnical investigation supported by observations and collection of groundwater data with geo-environmental and hydrogeological and hydraulic data depending on the type of the proposed project. Say for bridge we have to collect hydraulic data, and say for a landfill we have to collect geo-environmental data like this. So this may lead to establish appropriate constitutive model with optimized engineering design, which will result in successful completion of the project. So here a flowchart has been given, it can be seen, so I am not reading it. Now, as I have told that we have to correlate between the field test and laboratory test. There are several field tests here. I am not reading. There are non-destructive tests, invasive tests, and also combination of the two. Now, ultimate aim is to carry out limit analysis and serviceability analysis so that the ground can endure the stress properly, and also within the serviceable limit, it should be the deformation should be there so that settlement does not permissible the allowable limit. So for this limit analysis, we need soil strength in the form of shear parameters, bulk unit weight and groundwater conditions, and of course for deformation analysis, we need these factors like Young's modulus, Poisson's ratio, shear modulus and bulk modulus. Now, focusing on this, I should come on the particular study I am going to present here. That is actually a research work carried out by two or three of my students. Dr. Shoibal Chakraborty, who has obtained his PhD, Dr. Roshimanto Sengupta, he has also obtained his PhD, and Paulomi Ghosh, he is doing PhD. Although his work is a little different, but he has helped in this work also in many ways. Now, actually, for a long time, we have been working on improvement of subdead soil by different methods. I will focus here focus on two methods. One is improvement by addition of lime, rice as cash, lime and rice as cash in different proportions to the original soil. And another is overlaying of compacted fly ash with geotextile at interface. Now finally what has been done here, that a bituminous pavement with granular base and subbase layers have been designed using IRC 37 guidelines and IIT PEP software to supplement the findings of the severe values from those two improvement methods. So this is the first study, that is lime and rice as cash. Now materials used here are soil, lime and rice as cash. The properties here, I am not reading it out, but it is actually given here, the properties of soil as we obtain here are this. Now properties of RHA, this is also given here, and then comes the number of mixes. Actually, considering soil lime mixes and soil RHA mixes, we have taken, and soil lime RHA mixes, we have taken total number of 30 mixes here. So naturally, what tests have been done, that is LLPL, that is for identification, and then standard total compaction test, and then severe test at OMC. So here, actually, let us go to the cards directly, because I have made already late. So what is there? This is the curve for liquid limit versus percentage of lime for different percentage of RHA. So observations are this: when only lime is added, LL decreases with increasing lime percentage. When only RHA is added, LL increases slightly with increasing RHA percentage. And when lime and RHA are added in combination, then LL decreases with lime percentage for a given RHA percentage. Then variation of plastic limit here with same percentage of lime for different percentage of RHA. It is seen that when RHA is added, PL increases with increasing RHA percentage. When lime and RHA are added in combination, PL increases up to 6% of lime content, that is here, for a given RHA percentage, beyond which more or less it is becoming constant or slightly decreasing trend. Then comes plasticity index. When lime and RHA are added in combination, plasticity index decreases with increasing lime percentage for a given RHA percentage. Then comes maximum dry density with lime content for different RHA content. So curve of MDD versus lime percentage, as we see, when only lime is added, MDD decreases with increasing lime percentage. When only RHA is added, MDD decreases with increasing RHA percentage. When lime and RHA are added in combination, MDD decreases with lime percentage for a given RH percentage. This is clear from the figure. These are the observations. Now, then optimum moisture content versus percentage of lime. Now, when lime and RHA are added in combination, OMC increases considerably up to 6%, that is here. And then for a given RH percentage, and a decreasing trend occurs then beyond 8% lime content. That is here, from 8% it is decreasing. Now comes unsoaked severe. So when lime and RH are added in combination, unsoaked severe increases considerably up to 6% of lime, that is here, and then it is falling down. Now, this is soaked severe. Now, when lime and RH are added in combination, soaked severe increases up to 6% of lime content for a given RH, and then it decreases. Now, the maximum severe with what we have worked, that occurs at with a value of 29.82%, that is obtained for 6% lime and 6% RH combination under soaked condition. Then some statistical analysis has been done, and by multiple linear regression method, severe value, both soaked and unsoaked, has been obtained in terms of LLP, LPI, MDT, OMC. Now the second study, that is improvement of soil substrate overlaid by compacted fly ash and geotextile at interface. Now here also the material used are soil, fly ash and geotextile. So properties of soil are given here. Next comes the composition of fly ash. Next comes the properties of fly ash. Next is the properties of geotextile. Now comes the test program. Actually, what we have done in the severe mode, which is 126 or 27 millimeter height. So now we have taken 50% height, bottom 50% height for clay, and top 50% height for fly ash, and at the interface we have provided geotextile layer. So thickness ratio, that is actually fly ash height by soil height, that is 1:1, because both are same. Now molding water content for standard vector energy, it is starting from OMC. So it is going 16, 22, 28, 34, 40, and for modified Proctor energy, it is going to 12, 18, 24, 30, 36. But it is to be noted that molding water content of fly ash has been kept at 41%. Now comes the severe values. So for the standard Proctor energy, as the molding water content increases, the severe value decreases with 0.24 at 34%. And here for modified Proctor, it is also decreasing in this way from 3.87 at OMC 12% to 22.22, right? So now here the what happens, what actually we see that for this this is actually for clay and fly ash. These are the results. But for 1:1 height in the severe mold with fly ash soil composite matrix, here we see that when it is going to 16% to 34%, the value falls from 14.09 to 6.2, and when the molding water content falls from rises from 12% to 36% in case of modified Proctor energy for the same matrix with the same thickness ratio, then it falls from 25.9 to 2.84. So another thing is that although it is not presented here in the first study, when we are going to OMC, then PBR is falling, but we have later we have introduced one improvement factor. That improvement factor is becoming less, but here this improvement factor, it has increased with molding water content. So this is the summary of the findings, what I have already told you, so I need not repeat it. That it is decreasing from 14.09 to 6.2 for standard proctor, and 25.9 to 2.84% for modified proctor of the same thickness ratio, with increase of molding water content from 16 to 34% for standard proctor and 12 to 36% for modified proctor. And with compaction energy, the CBR value at OMC increases from 14.09 to 25.9. Now comes this improvement factor, which is actually CBR value of the matrix, ratio of CBR value of the matrix to CBR value of the original soil. From the graph, it is seen that beyond the OMC, it is gradually increasing. So therefore, we got some idea that at higher water content, this improvement may give some useful result. So, and for the first improvement, improvement near about OMC, that may give a good result. So this is actually comparison between the study, what I have told you. It is given here in terms of improvement factor. We can see that a maximum improvement in CBR value is 6.65. It occurs with soil with 6% lime and 9% RH at OMC. This is for unsoaked. As for soaked condition, improvement factor is 8.52, which occurs for 6% lime and 6% RH content. And in the second study, maximum value of improvement factor for under soaked condition is found to be 25.83, which occurs for highest molding water content of 34%, but at a molding water content of 16% near OMC, improvement factor is not so high, it is 4.7. So with this idea, actually, we wanted to think like that the method of improvement of soil substrate overlaid by compacted fly ash and geotextile at interface should prove to be better means of enhancing the soil character at high water contents. But first method of soil improvement with lime and RHA, actually, is a better result at or near OMC. So with this idea, we wanted to supplement this by a pavement design with guidelines of IRC 37 2018 and IIT PEP software. So for that, actually, we have taken some design parameters, considered some design parameters given here, that is 4-lane divided carriageway, initial traffic in the year of completion of construction 5,000 CBVD, commercial vehicles per day, traffic growth rate per annum that is 6%, design life 20 years, vehicle damage factor 5.2, same for both directions. Now, from the formula of IRC 37, we have found out the N value, that is, it comes to 131 MSA, putting all the values over here. Now, since it is more than 50 MSA, so SMA, that is stone matrix asphalt, and GGRB, gravitated rubberized bitumen, or GC, bituminous concrete with modified between surface course, and TBM binder base layer with VG40 has been considered as per IRC 37 guidelines. A trial section with 190 mm of total bituminous layer having 40 mm thick layer, the surface layer, and 70 mm thick dense bituminous macadam 2 and 80 mm thick bottom ridge dense bituminous macadam 1. So this 80 plus 70, that is 150 plus 40, so it is 190 mm. This is followed by 480 millimeter total granular layer, 250 millimeter thick WMM, 230 millimeter thick GSP has been considered. Now, considering 90% reliability, we have found that, of course, from the formula given in IRC 37, that allowable vertical compressive strain on subgrade is 0.30301 and horizontal horizontal strain at the bottom of bituminous layer is 0.30150. So with this, we have solved actually 4 problems. That is soil 1, the first case, original soil. Then soil 1 plus 6% line, 6% RHA. The severe values, as we have seen, they have been indicated here. And soil 2, that is untreated soil, it was 0.24 at the highest water content, 34 or 36%. And when under that condition, it is overlaid, then overlaid by fly ash with geotextile at interface, then it comes to 6.2. And then again from the formula of IRC 37, we have found out resilient modulus of subgrade as these values and resilient modulus of granular layer as these values. So then we have analyzed it with values given in IRC 37, that is Poisson's ratio of 0.35 and single wheel load of 20,000 Newton and tire pressure of 0.56 MPa. So the obtained values of critical strengths, there I have already told you that by formula they comes to this. So this is a typical input window of IIT PEV analysis. This is a typical output window of IIT PEV analysis. Now what are the results? The results have been shown here. So for the first soil, if we look at, so the stress that is developed as obtained by IIT PEV, so that is greater than the stress allowable stress. Is the horizontal vertical, not stress, it is actually strain. I'm sorry, it is vertical strain, vertical compressive strain, and this is horizontal tensile strain at the bottom of bituminous layer. So this is also becoming greater than the allowable value. So this soil is totally failing. Similarly, soil 2, original soil 2, that is also failing because the stress obtained is greater than the strain obtained are greater, and here when we are improving it, that is soil number 2, improved with case 1, that is addition of lime and RHA, then actually we are seeing that this is within the limits. Similarly, when it is actually when soil 2 is improved, that is case number 4, then also we are seeing that it is within the limits only, except the last one, it is 150 and it is slightly increasing. Now, if we just could take a little lower moisture content, it would have been within the range, and it is almost within the range. So this is the results of the IIT PEV. This is written here actually what I have already told you, so I don't need to read it. Now the conclusions of the entire study is that soil characterization and in situ test interpretation have been evolving from basic empirical recommendation to a more advanced area which requires a thorough knowledge of material behavior. In general, cross-correlation of measurements from different tests is recommended to understand the complex in situ behavior. Now, upon comparing the severe characteristics of soil lime RHA matrix method and soil geotextile fly ash matrix method of subgrade improvement, it has been observed that under unsoaked condition, a maximum improvement of severe value by a factor of 6.65 occurs when soil is mixed with 6% lime and 9% RHA content at OMC. And this becomes 8.52 under soft condition when 6% lime and 6% RHA are mixed. In case of soil geotextile fly ash matrix method of subgrade improvement, the maximum value of improvement factor under soaked condition is 25.83, which occurs for highest molding water content of 34%, irrespective of compaction energy. But at a molding water content of 16% near OMC, the improvement factor is 4.77, it is falling. So method of improvement of soil subgrade overlaid by compacted fly ash and geotextile at interface proves to be a better means of enhancing the soil character at higher water contents. But the method of soil improvement by addition of lime RHA somewhat yields a better result near OMC. So the IIT wave analysis also supplements same thing, and as we see that this 6% lime and 6% RHA content mixed with the soil at OMC under soak condition yields an effective level of subgrade improvement as obtained. Critical strains are well within the permissible limit of the trial prevalent section. Also, soil geotextile fly ash matrix method of subgrade improvement may prove to be adequate for severe values measured at lower molding water content less than 34% under soak conditions. Now, these are the references of the work. Thank you very much for your patient hearing.
Thank you, Professor Mukherjee. We can actually a little bit over time, so we can take one question maybe. If there is any question? If there is no question, I have one question that in the geotextile you are using fibers or?
Excuse me?
In geotextile you are using some kind of fibers?
Yes, it is fibers.
Okay. So when you have improvement in PPR, is it primarily due to fibers or due to the fly ash?
It is primarily due to fly ash, and when we are putting geotextile, then their drainage occurs, so improvement is coming more.
Thank you, Professor Mukherjee. So nice of you.
Thank you very much.
Now we will go. You have something to say, Jay?
No.
Okay.
Go ahead.
We can move to the next presentation. I think Dr. R. Chitra's book has a paper on comparison of theoretical and laboratory permeability for coarse-grained soil at different ground conditions. Manish, Dr. Chitra, who is presenting? Or Satyajit Roy? Arti?
Good morning, sir. Good evening, sir.
Satyajit.
Good evening, sir.
Yeah. Please, you can share your presentation and start. And please be in time in 6 minutes, if possible. Professor Mukherjee, can you
Yes.
Can you mute the mic?
So what is that when you mix that water in soil, it absorbs the rainwater or irrigation water, and it swells in the soil, swells and becomes gelatin material.
And may I request all the presenters to be ready with their presentations and everything, so that we can start immediately as soon as possible.
During the evaporation, it slowly releases the water, including the polymer structure, and so that the water can flow in any cave.
Good evening, sir.
So,
Good evening.
My screen is visible.
You can share the screen. Not yet.
Sir, I have shared. I have shared.
volumetric water content is necessary.
Okay, sir, I'm
But the
doing it
direct
again.
measurement of volumetric water content is not suitable for field monitoring. In such cases, indirect measurement using neutron bulbs or other field
You can
parameters
present your
is
presentation,
advised.
sir. So just click the present now option.
Most of the
Yeah,
electromagnetic sensors
it's
fall
coming
under
now.
concept of this electromagnetic wave propagation,
Coming, sir.
which measures soil
It's coming.
temperature,
Open the file now.
humidity, and electrical conductivity, and then relate it with the soil community water content. So the accuracy of these sensors
So
largely depends on the
Professor
number of
Samadia is also here.
parameters which needs to be validated for
Welcome, Professor Samadia.
before using it in field for any
Okay.
specific material. So the
Good evening, Chairman, sir. Good evening, Co-Chairman, sir, my seniors and all. My name is Satyajit Roy. I am from Central Soil and Material Research Station, New Delhi, which is an attached office of Ministry of Jal Shakti, Department of Water Resource, River Development, and Ganga Rejuvenation. Today's my topic is comparison of theoretical and laboratory permeability for porous soil at different ground conditions.
one soil
Here I have chosen four
soil
type of
has
sand and I have compacted the different relative densities
the particle size may
and I have found the laboratory probabilities of those sands and I have compared those laboratory probabilities with theoretical probabilities.
soil is reported in the literature that
This is my
the
preview.
particle probability is
Actually, in actual ground condition, density and permeability varies from place to place. That's why I have taken different relative density to compare the laboratory permeabilities. Moreover, theoretical correlations are quite effective for preliminary assessment of permeability during feasibility stage. However, at the designing stage, actual measurement of permeability is very important for structural integrity. Here I have compared different lab probabilities with theoretical comparabilities.
in three different
The
concentration
material I have selected, four type of sand I have selected. One is from MP sand, Sindh River sand. The second one is Yamuna River sand. Third one is Rajasthan grass sand. And fourth one is Indore standard sand. I have did the mechanical analysis and from the table I can see that out of four, two are of medium sand and two are of fine sand. That is sample number 2 and 3 is fine sand and sample number 1 and 4 is medium sand. This is the great grain size distribution curve of my samples. Now the from grain size distribution curve, these are the properties I have find out. These are the values D10, D20, D30, D60. These values have been used for calculating the theoretical probabilities values. And for the laboratory probability, since this is sand, so we have first find out the relative density of those sands and have applied those in calculating the in finding the constant and probabilities. This is the minimum and maximum relative density of different sands. The like river sand MP has 1.44 values, like all for maximum 1.76 is the highest, and that is of river sand MP. In literature, there are several formulas for calculating the theoretical probabilities, and I have chosen these 7 formulas for calculating the theoretical probabilities. But these equations have their own boundary conditions, and based on their boundary condition, I applied these formulas on a particular soil, like Hazen formula, Quincy-Corman, Breyer, Schleicher, Terzaghi, USBR, Elmoni, and Sale. This is my table showing the permeability values of theoretical permeability values. You can see in the Rajasthan Hazen in the first column, I calculated the use the Hazen formula. In case of Rajasthan grass sand, I have shown Na because the boundary condition in Hazen is U should be less than 5, but in Rajasthan sand is coming out as 27. That's why I have not applied this formula here. Again, Tarzagi is giving the formula for poor sand. So I have my sand is fine and medium, so I haven't applied the Tarzagi formula here. And USBR also is applicable for fine sand. My Yamuna and Rajasthan sand is USBR is for medium sand. My Yamuna and Rajasthan is fine sand. I have applied USBR in case of Yamuna and Rajasthan sand. Now this is the result of constant height permeability test. I have compacted the statement specimen at different relative density, like 95% of maximum relative density, 85% of maximum relative density, then 75% of maximum relative density. One is dry or loose packing, and one under wet condition. And these are the values all comes in the range of 10 to the power minus 4, minus 5, and minus 3. But in theoretical probability values, they are in the range of 10 to the power minus 1 to 10 to the power minus 2 range, centimeter per second. Now the comparison. The comparison theoretical probabilities, you can see that the Sindh River is the highest value, and the Rajasthan sand is, Prasid sand is the lowest value. And among all the formulae, I have found the Kozny-Karman formula has given the best estimation for sample number 1, 2, and 4, and Breyer has given the best for estimation for sample number 3. For dry packing also, dry packing, this is the trend. Indoor sand is the highest value, and the Rajasthan sand is the lowest value. So, however, sand containing 17.9%, that is Rajasthan crust sand, is having lowest value. Maybe it's because of silt helps in filling the voids in between the sands particle, thus reducing the permeability values. Now the wet packing. I have packed the sample in presence of water also, and interestingly, it has been seen that when I pack the sample in presence of water, the relative density of sand has increased in a range of 32 to 58% range, increase relative density. Now the dry packing at 95, 85, and 75% maximum relative density, and it has followed the trend as indoor sand is the highest and Rajasthan crust sand is the lowest value.
Mr. Roy, please conclude.
When I did the overall comparison, I have found that the theoretical values has the maximum values, and the 95% relative density, which is more dense, has the lowest values. In between, one more interesting thing is that in between 75% relative density and 85% relative density, the sample which I packed in presence of water, okay, sir. When I've seen in presence of water, it comes between 75 and 85% relative density. So factor affecting permeability, theoretical CU at D10 is more important, and for laboratory, percentage of seal degree of permanence and packing in percentage is more important. This is my conclusion. Kozny-Karman is the best for 1, 3, and 4, and 95% relative density has given the lowest permeability values, and the relative density increased in presence of water, and this is the trend, final trend. The theoretical values, theoretical permeability has the highest values, and 95% relative density has the lowest value. Thank you.
Thank you. Any questions?
Any questions?
Okay, I think let's move on to the next presentation then. Anju Mary E and Chandrakaran. Yes.
Thank you.
Yeah, thank you. Thank you. You can stop sharing here. Just press the button, blue button.
I think the paper number 4 is going to present the geotechnical investigation for upflux bunds.
Oh, okay. I missed one, I think. So next one is Jayan VK and Satyajit.
Yeah, Mr. Roy was, I think, supposed to present the same thing, huh?
Oh, okay.
Yep.
So Jay, you are doing a better job than me. Would you like to take over from here for the presentations?
I will do that. We'll do that. Yeah. Yeah, Mr. Roy, you can start. Yeah, Mr. Jay or
Yeah,
Who is going to present?
I'm Vikas Kumar Jain. I will present this paper. Hello, am I audible?
Okay, sir.
Yes.
Yes, you are audible.
I'm going to start. I'm Vikas Kumar Jain from the same office from which where Mr. Satyanjit has earlier presented the paper. I will not do my introduction. My topic for this today's presentation is geotechnical investigations for the flux month of a barrage project in eastern India. My topic for this today's project is a barrage project. Subarnrekha multipurpose project is one of the major projects where it is a multipurpose project where is the Kharkai barrage is one of the main component. This barrage is situated at 40 kilometers downstream of the proposed Isha Dam on the river Kharkai. This Kharkai barrage and this canal systems are proposed to supply the water to the municipal and agriculture purpose. The axis of the barrage is fixed on the downstream of two rivers. One is the Khargai river and other is the Sanjay river. The work for the construction, the work for the borough area selection for the construction of the flux bank was given to our office, and we have taken up this work and submitted our report. This is the picture for the construction of the barrage. This is the river, main river Khargai. When this project was awarded to our office, one of the two of the senior officers have visited that project site, and they selected 8 potential borough areas. After that, myself and one of my colleagues, we have visited the project site and we have collected the 20 representative soil samples from these 8 potential borough areas. This is the method for this is the trench 3 meter by 3 meter by 3 meter, and this is the picture how we collect the samples. After collecting the samples were sent to our laboratory for soil investigations. Here we do mechanical analysis test, atomic limit test, Proctor compaction test, expressive gravity test, unconfined compression test, drag shell test, laboratory permeability test we do swelling index test, we do chemical analysis test, and we also do the dispersibility characteristic on soil samples. This test contains 4 tests: pinhole test, crumb test, double hydrometer test, and chemical analysis test. Except this dispersibility test, all the tests are having as per IS code. But for the dispersibility test, there is no IS code, and we are trying to prepare IS code through our office level. We do the mechanical analysis test and atomic limit test on all the 20 soil samples which we have collected, and from the results from the analysis, we found that out of the 20 soil samples, 3 soil samples fall under CL group, means clay having low compressibility. 7 falls under CI group, means clay with intermediate compressibility, and 8 falls under CH group, means they are the clays having the very high compressibility. 1 falls within the CL and CI boundary conditions, and 1 soil sample falls under MI conditions having the silt having intermediate compressibility. This is the grain size distribution curve for the first 10 samples. This shows that all the soil samples are having mainly clay and silt between 70 to 80%. All the 20 soil samples having the same characteristics. These are the results for the Proctor compaction test. We have selected 1 soil sample from each of the borough area. We have done a compaction test and expressive gravity test. From these test results, we could recognize that the specific gravity, the MDD of all the samples vary from 1.72 gram per cc to 1.89 gram per cc, and the OMC varies from 12.5% to 15.5%. And this result shows that the soil samples are having the tendency of achieving good to very good compressibility, compaction dimensions. From the specific gravity results, we could see that the specific gravity varies from 2.67 to 2.78. These are the curves for the 8 soil samples. Compaction curve. We have done a laboratory test
one each sample from 8 borrow areas, and it indicates that all the soil samples are having impervious drainage characteristics. We have packed all the soil samples at 98% MDD. These are the traction results. We have selected 3 soil samples and we have done the traction test with the consolidated undrained test with the measurement of pore pressure. These values indicate that the soil samples are having good shear strength characteristics. We have also done the dispersibility test on 2 samples. We have done pinhole test, double hydrometer test, current test, and chemical analysis test on the pore water extract conducted on the selected borrow area materials. This test indicates that all the borrow area materials are having non-dispersibility characteristics. Out of these 4 tests, pinhole test and the double hydrometer test are more reliable. This is the conclusion that based on the borrow area investigation carried out on the soil samples collected from the 8 different borrow areas, it was recommended that the material from all the 8 borrow areas were found suitable for the construction of the impervious core of the flux. We should also take, because 7 to 8 soil samples are falling under CH group. The care should be taken while we are doing construction for the CH group. Care should be taken by the project authority. Before I conclude my lecture, I would also say thanks to our director, Mr. S. L. Gupta, my group head, Dr. R. Chitra, who has shown confidence in me and for preparing this lecture. Thank you, sir.
Thank you, Mr. Vishkas Jain, for this your presentation.
Thank you, sir.
We will take one, let's say, question. If anybody want to ask some question onto it, you can take one question.
Yes, sir.
Okay. If there is no question, we can move on to another, let's say, paper.
I can ask a question maybe. Yeah.
Yeah.
So, you found the soil to be dispersive, right?
It is non-dispersive. All the samples were found non-dispersive.
Non-dispersive completely.
Yes, completely non-dispersive.
So, what was the conclusion about this crumb test and all that?
For the crumb test, we found that there were no cloud formations.
Okay. And pinhole test
water was very clear, and the whole size is also very
okay, that way. Okay. Thank you.
Thank you, sir.
Thank you, Professor Prashant. Now I will invite Anju, Mary and Chandrasekharan. The paper title is Prediction of Engineering Properties of Kerala Soil.
Hello, sir.
Yeah.
Am I audible?
Sanju. Yeah, you are audible. Please start your presentation.
Okay, sir. Okay, good evening, everyone. Myself, Anju Mary alias. I have completed my MTech in Geotechnical Engineering from Karunya Institute of Technology and Sciences, Coimbatore. And today, I am here to present my project titled Prediction of Engineering Properties of Kerala Soil. We all know that soils are produced as a result of denudation of rocks. The engineering properties are determined either inside or in laboratory. But the main disadvantage is that it is time consuming and costly. So, for small projects, these properties can be predicted from index properties. These index properties are easy to determine, so we can predict the engineering properties from the index properties. The engineering properties considered in this study are shear strength parameters, that is cohesion and angle of internal friction, and coefficient of consolidation. The engineering properties of Kerala soils was predicted. Why Kerala soil? This is because the soil data report which I collected was from various geotechnical consultancies in Kerala. And in this study, the correlation of engineering properties with index properties was determined. and its applicability on Kerala soils was verified. Kerala state is located on the southwest coast of India, and two types of soil are seen mainly here, that is soft soil and lateritic soil. The scope and objective of this study is to predict the applicability of already available equations in the Kerala soil, then to perform regression analysis and suggest the predictive equation, and to prepare and study models using artificial neural network, that is ANN. The methodology used in this study is that at first, soil report was collected from various consultancies in Kerala. All the data was combined and mean, standard deviation and variance of all data was determined and a data set was prepared at first. Then the regression tool of MATLAB was used to find the relation of this engineering property with the index property. These equations were suggested by various people. A number of equations are already available, and I have selected the equations with RMSE value low values I have selected. The applicability of these equations on Kerala soils was checked, and the root mean square error values was noted. And these are the root mean square error values when these equations were applied on Kerala soil. The relationship between engineering property with index property was also confirmed using the artificial neural network. It is an analytical technique. It can be trained and it consists of mainly three layers, that is the input layer, hidden layer and the output layer. It was found that both cohesion and angle of friction, internal friction has relation with SPT value and moisture content, while the coefficient of consolidation had relation with bulk density, percentage fines and liquid limit. This is the user interface of regression analysis of MATLAB, and the figure shows the relation of SPT value with angle of internal friction. Like this we get the R squared value, that is the coefficient of determination. These are the predictive equations developed after performing the regression analysis, and it's the equation for cohesion, angle of internal friction and coefficient of consolidation. The corresponding R square values are 0.75, 0.8 and 0.88, and we can also see that the RMSE values. While comparing the RMSE values for the already available equation and predicted equation, the predicted equation has less RMSE value, which shows its effectiveness. This figure shows the relationship of properties using ANN. This is also the user interface, and we can see the R equals 0.9. That's the R square value using ANN software. Okay, this slide shows the R square value. That is the coefficient of determination values that we have performed in both regression analysis and ANN artificial neural network. And we can see that the R square value for ANN is greater than that of the regression analysis. So it can be concluded that equation suggested by Mustafa had RMSE value of 0.22 and 3.28 for cohesion and angle of internal friction respectively, while the predicted equation which we have predicted has an RMSE value less value comparatively. Similar is the case of equation suggested by Asma for coefficient of consolidation. And also ANN is proved to be more efficient than the linear regression analysis, and also the predicted equations can be used for Kerala soil. These are the conclusions from this study. These are my references. Thank you.
Thank you for your presentation. Any questions?
So probably I'm going to ask questions, all the questions on their behalf.
I also would like to share, why you want to predict when you can test.
Perfect.
Sir, once more, can you repeat, please? I didn't hear.
Yeah, I just would like to say that why you want to predict the property when you can actually test it.
Yeah, sir. Actually, these tests I have collected from various consultancies, and I have performed this regression analysis and predicted equation and compared with the original test. So it found for more than 90 samples I tested, and it found to be it predicted the nearly the same values, and also RMSE values was less also.
So anyway, it's okay. What you did was you collect the data and then put it something into ANN and then try to see how best fit you get it, and then you predict the equation. That's what you did, isn't it?
Yes, sir. Yes, sir.
Yeah.
So there is one question in chat box.
Yeah, this one question
Does
is from.
ANN
Does ANN modeling provides a prediction equation similar to regression analysis?
No, no. Actually, the equation I predicted was just from regression analysis, and I confirmed the relationship with, of these index properties with the engineering properties in ANN using ANN. ANN will not provide equations, prediction equations.
Okay, fair enough. Okay, let us move to the next presentation. The next presentation is durability study on core fiber reinforced soil by Muthuram M and Dana Teja M.
Good evening, sir.
Yeah, good evening. Are you going to present?
Yes, sir.
Yeah, please, let's say start your presentation.
It's not.
You need to go to present now.
Yes, sir.
Yeah.
Is it visible, sir?
Yeah, it's coming up. Just put it on the presentation mode.
No, okay, sir. Is it visible, sir?
Yeah, it's okay. Okay, please start your presentation.
Good evening, Mandal. I am Manakala Dhanateja. I'm doing I'm studied my MBA Soil Mechanics and Foundation Engineering Division of College of Engineering, India, Anna University. My title is Durability Study on Coir Fiber Reinforced Soil, and it is created by Mutharam M. Professor Dr. Mutharam. Brief introduction about my project is, as we know, soil is a complex material. We need to know the problems, all type of problems related to the soil or foundation. We need to stabilize the soil. So for there is several types of methods are used for soil stabilization. So I am choosing this coir fiber, which is natural material, and also another material is there. It is jute fiber. So I am going with the coir fiber. It is a coconut fiber. We can use this for slope protection, river protection, and also for payments. Mainly nowadays they are using it for payments in I think in Kerala. In this coir fiber, the main problem is it is a natural material. So durable is one of the major properties we need to know about this coir for natural fibers. In order to increase our natural fibers, we need to successfully treat it with bitumen or copper-based materials, phenol, or some other patent chemical compounds. So I studied some literature. I give brief about the literature reviews due to less time. Which is the reality here an effect of natural coir fibers on severe strength of soil subgrade. In this literature, he used 0.5 to 3 centimeters of varying length and 2 to 8 of varying percentage of total weight of soil, and also he also used CACM 400 coil geotextile. He placed with different positions. He get better results at 5% and 1.5 centimeters 5 coir fiber, and also he get better results at top position of soil samples compared to other places. And Muthu et al. He also done using coconut coir fiber for subgrade strength, for increasing subgrade strength in clay sand. He, he done UCC test and soaked severe test for increasing the soil strength with the different percentages and with the different percentages and also different lengths. He get a high value at 1.2 percentages and 3 centimeters of CCF. I mean the coconut coir fiber. He is Shukla et al. He also done soil stabilization using coconut coir fiber. He taken a local some expensive soils. He done different percentages for compared to of dry weight of soil. He taken and he done unsoaked and soaked seaweed test. He also get better results while inclusion of coconut coir fiber. The soaked soil seaweed value increases 3.2 to 8.6 and unsoaked values increases 8.1 to 13.2. With 1% coconut coir fiber. It is a optimum fiber. He done because he get answer secret and conclusion because while it is while increasing coconut fiber, it is increases the strength and because it is composite of effect of coconut fiber changes the brittle behavior of the soil to ductile behavior. And some other three literatures I said Harshita Bairagi and Akhil Goyal and Abdul Jabbar Khan. These are done jute fibers. They taken jute fiber as a natural for increasing soil stabilization. They also this process also same by as coir fiber is. They also getting better results for increasing jute fibers. But in southern size, it is used maximum used as coir fiber. Coming to methodology, these are my methodology collection of samples, clay soil, coir, and characteristics of soils, both index and major properties. Both coir fibers 0.5 to 1.5% fiber are stabilized. Again, compaction test, CBR and UCC. I find the optimum fiber content. After that, I coated with bitumen and I done UCC test separately for HCl concentration water as pore fluid. And then I compare I comparison of results and discussion and then conclusion. These are the material soil. The natural soil is collected from Perambakam village near Charanagar, Tamil Nadu district, Tamil Nadu state, Changalpattu district. These are the soil properties you can see in the right side. I got after doing index test, I get that these are the results I got. Soil classification, it is a clay soil and highly. These are by conducting laboratories. These are the results I got for soil. Stabilizers used as coir fiber. These are the coir fiber. These are taken directly. These properties of coir fiber are taken directly from the industry where I collect the coir fiber. But I taken the 20 length of the coir fiber. And
Mr. Teja, you need to be quick enough. You have only 6 minutes.
Okay.
Go fast.
Sure, sir. As a bitumen emulsion as a coated material, which has water content 46% and it is brownish black color. It gives a better results for either. And concentration HCl for checking the durability. I use it as concentrated HCl as pore fluid, and then doing the UCC test. I compare the results. It is a 5 ml of HCl acid we use in 600 ml of tap water. It is almost one pH value is 1.222. Theoretically, these are the test results and discussion. Coming to test results and discussion from the compaction test, we can observe the moisture content while increasing the percentage of coir fiber. 0.5% it gives a high value compared to the others, and maximum dry density at 0.5% is the less value compared to others. Up to 0.5% is decreased and then it is increasing. It is because the tendency of coir fiber has tendency of absorb moisture content, and also it is very less weight compared to the soil particles. So due to compared to the volume, it may be decreases MDD, and further increases it increases the MDD dry density as a same reflected to optimum moisture content also. Coming to severe test, in severe test it is almost while increasing the coir fiber, it is increasing the severe value. While even if you increase 1.5% more than 1.5%, it is increasing the values. Even in addition of 1.5%, it is approximately 50% increase of severe value got shown in the result. And then I done the UCSC test. Compared to in UCSC test, I take the sample size is 3.6 centimeters diameter and 7.5 centimeters length. I prepare the sample. This in right side I shows arrangement of soil samples for without stabilization, with stabilization, with unstabilized soil and stabilized soil sample. These are the UCSC test results I got at 0.5%. Compared to these results, at 1% I got higher value. It is almost increasing to 17% compared to unstabilized soil. So I taken the 1% as a optimal fiber content. From this test, I taken as 1% as optimal fiber content for checking the durability test. Coming to durability test, I didn't UCSC test. This gray color shows is without fiber, and green color shows is untreated fiber, and red color shows treated fiber. Treated means I done with bitumen emulsion. I treated the coir fiber. I done 7 days curing and 30 days curing test. I compared the results for 7 days and 30 days. I done a UCSC test compared to this. It is inferred that the inclusion of coir fiber into the soil as an information shows higher compressive strength, and also bitumen treated coir fiber has more durability to treated untreated coir fiber compared to untreated.
Mr. Teja, please conclude.
I'm coming to conclusions. So based on this laboratory investigations, it is concluded the compaction characteristics of soil is increased by addition of coir fiber. The CBR value is increases while increasing the soil. So unconfined and also unconfined compression stress also increases by increasing soil. At 0.5% of 1% it increases by about 17%. As far as the durable, coming to durability, while treated with bitumen coated fiber are more durable than uncoated fiber in acidic environment. Because I taken a HCl as highly concentrated HCl. These are the references I refer. And then thank you.
Thank you, Mr. Teja.
Thank you.
I have only one question. How many UCS samples you tested totally?
How many UCC tests, sir?
Yeah.
Sir, each I taken 2 trials, sir. For each test, I taken 2 trials, sir. For 4 different percentages, each one 2 samples I taken, sir.
Okay, but that comes out to be how many total number?
8, sir. For
total 8 samples.
8 samples for normal water as portfolio, sir, and for HCl also I done 7, and that is so 12. Yes, each trial I done 2 samples I tried, not exactly counted.
Okay, that's fair. Anybody else wants to have some questions? Okay.
I think next one is
let us move to next. Yeah, the next one is paper number 008, effect of curing period on geotechnical properties of lime-treated organic soils by Annie J. Surti, B. Abraham B.M. and Sridharan.
Yes, sir.
Yeah.
Sir, am I audible?
Yeah.
Sir, can you
start, please? Yeah.
Sir, can you see the screen now?
Yes, you can. Please start your presentation.
Good evening, one and all. Myself, Annie Joy, research scholar at Cochin University of Science and Technology, Kerala. I am here to present my paper, Effective Curing Period on the Geotechnical Properties of Lime-Treated Organic Soils. This is the overview of my presentation. Coming to the introduction, as we all know, organic soils are characterized by the high water holding capacity, low shear strength, and large compressibility. Lime stabilization is a proven ground improvement technique for enhancing the properties of clayey soils, but the presence of organic matter can induce negative effects on the lime stabilized soil. Based on the extensive literature review conducted, we could find that the effectiveness of lime stabilization gets decreased with long term. So we have formulated the objective of the present study as to study the effect of longer curing period up to 120 days on the geotechnical properties of lime-treated organic soils. This is the methodology we have adopted. For the experimental program, we have considered 3 soil mixtures. First one comprising of bentonite and 6% lime. Second consisting of bentonite, 50% organic matter and 6% lime. And third soil mixture containing 100% organic matter and lime. The following tests were conducted at the end of each curing period, starting from 0 day up to the end of 120 days. Coming to the materials used for the study, we have selected bentonite since it is free from any organic matter content. Next, we have chosen the artificial organic matter, that is vermicompost was used for the present study, and the properties are as follows. Next, the lime used was hydrated lime. Coming to the results and discussion, first is the effect of curing period on the liquid limit. From the table, you could see that for the bentonite plus lime soil mixture, the liquid limit went on decreasing with the increase in curing period. But when you consider the organic matter, with the increase in curing period, we could see that with increase in organic matter, the liquid limit goes on increasing. The same trend was observed for the plastic limit also. Next is the effect of curing period on free swell index. For bentonite plus lime soil mixture, free swell index was seen to decrease, whereas in the case of bentonite, lime and organic matter mixture, the free swell was seen to increase and then decrease. Now coming to the strength result, unconfined compressive strength. These are the results plotted. Here you could see that the green curve represents bentonite plus lime soil mixture. It is very clear that as the curing period increases, the UCS strength increases in the case of bentonite lime soil mixture. But when you observe this red curve, which represents organic matter plus bentonite plus lime, initially there is a slight increase in strength up to 90 days, after which it goes on decreasing. And when you compare it with the strength of bentonite and lime, you could see a decrease of about 73%. Similarly, when you consider the blue curve, that is for the organic matter plus lime, here also you could see a similar trend, like an increase in strength up to 90 days and then a decrease. And here we could observe a decrease in UCS strength of about 77% when compared to that of bentonite lime at the end of 120 days. Now we could see that in the case of soil mixture containing organic matter, there is an aggregation of organic matter due to which flocks are formed. So initially we could observe an increase in strength, but as time progresses, this organic matter coats the clay minerals, inhibiting the reaction between lime and clay mineral, which led to the decrease in unconfined compressive strength. Next is the void ratio pressure relationship. Here also we could see that as the organic matter content increased, the void ratio decreased, which led to the increase in compressibility. Now this is the variation of compression index with curing period. Here also for bentonite plus lime soil mixture, we could see a decrease in trend, but as the organic matter increase, you could clearly observe that at the end of 120 days, the compression index started increasing. Now, in order to confirm the above results, we conducted microstructural analysis. For the present study, we have conducted FTIR spectrum analysis. And from this figure, you could clearly see that for any particular frequency, the transmittance goes on increasing with the increasing organic matter content. The reason behind this is that with the addition of organic matter, there is an increase in pore size due to the aggregation, and this increase in pore size confirms the results that the compressibility increases and the UCS or the unconfined compressive strength of the soil sample decreases with the increase in curing period. So coming to the conclusion, liquid limit and plastic limit increased, the addition of organic matter, the strength decreased, compression index increased, and pore size increased. So from this, we could conclude that the effect of lime stabilization is nullified by the presence of organic matter. So these results really contribute to a better understanding of impact of curing period on stabilization of lime-treated organic soil, and will surely provide a warning to the geotechnical engineers while choosing a ground improvement method for organic soils. These are my references. Thank you.
Very interesting observation of the presence of, say, organic matters on lime-treated soil. Thank you for your presentation.
Thank you, sir.
Any question?
I can ask only one question. that how do you apply this observation in the field?
Sir, yes, sir. Sir, actually, we have found this is only the first part of my study where we have found what are the changes or the influence of organic matter on the geotechnical properties. And in the second half of my study, I have conducted the mitigation analysis, and we have found that with the addition of sodium chloride, NaCl, we could reduce this negative impact of organic matter, sir. So this chemical treatment is effective. About addition of about 5% of sodium chloride is effective in mitigating the negative effect of organic matter, sir. We are doing that study now.
Okay, but you have to plan something, I think, for your field observations also, so
Okay,
that you
sir.
can apply it properly.
Thank you, sir.
Okay, thank you for questions and answers. Thank you, Professor Shivapriya, for participating into it. Let us move to the next presentation of paper number 10, which is the influence of density and degree of saturation on shear strength characteristic of marine sands by Natarajan K. and Siva Sankara Reddy DV.
So, Anijay, can you please stop the presenting?
Yeah, Mr. Siva Reddy.
Yes, sir.
Yeah, Mr. Dr. Natarajan. Are you going to present?
Yes, sir. Yes, sir.
Please start your presentation.
Yes, sir. The topic is influence of density and degree of saturation on the shear strength characteristics of marine sands by Dr. K. Natarajan and Mr. D.V. Sivasankara Reddy. Next slide. Contents of the paper is introduction, literature review, objectives of study, methodology, results and discussion. So, can you hear me, sir? Hello?
Yes.
Yes.
Please go ahead. We don't have much time. Yeah.
The shear strength of soil is not only the properties of soil, but also it depends on the density, moisture content, grain size, particle size, and gradations. Here we are going to see about the density and moisture content. Moisture content by means of the saturation of the soil. The attempt has been made to this work to study the shear strengths characteristics of marine soils along the eastern coast of Tamil Nadu, such as Pichavaram, Padayar, Navapatnam, and Samyarpeta. The boreholes are taken at a depth of 3 meter and 5 meter by conducting SPT tests. The soil samples were tested in the loose dry condition, loose saturated condition, and dense dry dense saturated conditions by direct shear tests.
Myself, D.V. Shushankar, going to present.
0.25 millimeter strain rate for all 32 testers. Angle of internal friction for the above soils for determined for the peak shear strength and the shear strength of the at constant volume. There is considerable difference observed in friction angle for the above two conditions. The difference is more for saturated soils. Higher values of friction angles were observed for the sands collected from Navapatnam and Samyarpeta region than the soils collected from Pichavaram and Padayar regions. This is due to the more angularity of soil particle in the Navapatnam and Samyarpeta region.
Sivasankara Reddy will continue this presentation, sir.
Okay, sir. This is this is the literature review which we are collected for this study. So, main objective of the study is to determine the angle of internal friction of soil at a different depths under varying soil conditions, like that is loose dry, loose saturated, dense dry, and dense saturated, and also to determine the horizontal displacement of soil at a different depths under varying soil conditions. So, methodology here the soil is collected from two different depths at four different locations. Shear parameters from direct shear test soil at four different locations, that is Pichavaram, Pajayar, and Nagapattinam and Samarapattai, at two different depths, 3 meter and 5 meter. The relative density is loose and dense conditions, and the soil is tested in dry and saturated condition. So results and discussions. This is the grain size distribution diagram of four different locations. The mostly all the soils are in sandy soils. Mostly the soil is in medium to fine sand at four different locations. So this is the graph shows the shear stress and normal stress variation for loose and dry state, loose dry and loose saturated at different depths, that is 3 meter and 5 meters. It is clearly observed that the that given normal stress, the shear stress value is increases comparatively in dry condition is more comparatively in saturated condition. So coming to the graph 3 is the same at a given normal stress condition, the shear stress is increasing comparatively in loose condition. The dry condition is more comparatively in loose condition. So the remaining figure 4 also shows the shear stress and normal stress variation at a 5-meter depth located in Pichavaram. So here also same thing is observed at a given normal stress, shear stress increases. So the same pattern we also observed at a 3-meter and 5-meter depths at a Pichavaram location. So these are the different angle of internal frictions the four different conditions: loose dry, loose saturated, dense dry, and dense saturated. So phi is the angle of internal friction is obtained at peak shear strength, and phi c is the angle of internal friction which is obtained at ultimate shear strength. So these are the angle of internal friction values at four different locations. One is Pichavaram, another one is Rajavar, and Nagapattinam and Samarapattai location. So the figure 6 shows the variation of shear stress and horizontal displacement for loose dry and loose saturation conditions at a 3-meter and 5-meter depth. So it is observed that with increase in shear stress, the displacement value goes on increasing. The more displacement is observed in loose saturation condition at a 3-meter depth compared to dry condition. So the same figure 7 shows the shear stress and horizontal displacement variation for loose dry and the dense dry condition at 3-meter depth located in Pichavaram. So here the displacement value with increase in shear stress, the displacement value is more in case of loose dry. Sorry, in the dense dry comparatively in loose dry condition. So the same thing is observed in at a dense dry and loose dry conditions at 5-meter depth located in Pichavaram. So
Yeah,
coming
Mr.
to the
Sivasan, please
conclusion,
conclude.
based on the results obtained from direct shear test soil samples, the following important conclusions to be drawn. There is a considerable difference between the friction angle using peak shear strength and the ultimate shear strength corresponding to a constant volume. The difference between the phi and pi CV appears to be least for the soils in dry condition as compared to the values when the soils are tested in saturation condition. The difference between the pi and pi CV is more in dense condition when compared to the loose state. In the case of soil tested in loose condition, it is observed that the value obtained from saturation condition is lower than that of dry condition. The higher difference between the values of pi obtained for loose and dense condition indicates better interlocking of soil grains due to the angularity of the soil. These are the reference which we are using for the study. Thank you.
Thank you very much, Professor Nagaraja and Siva Sankara Reddy.
Thank you, sir.
We can take one question over here. If anybody would like to ask question, please come forward. Okay, if no question is there, let us move forward.
Sharanya. Is Sharanya here? No. Sorry. Yes, Sharanya AG, Iralal M, and Shivaranshu Kumar R. No, Thyagaraja T.
Yeah, Mr. Natarajan, please mute your mic.
Okay, sir. Okay, sir.
Yeah. Sharanya is here. I think she has to share the presentation. Yeah.
Yes. Good evening, everyone. Am I audible, sir?
Yes.
Yes. I'm A.G. Sharanya, second year research scholar from National Institute of Technology, Warangal, Telangana, and I'm here to give my presentation on evaluating soil shrinkage behavior using digital image analysis process. So, without further elaboration, I'll get into the gist of the presentation. So every soil will undergo swell and shrink, and the volumetric strain is happening because of the change in void ratio with respect to change in water content. This volumetric representation of drying phenomena is expected to occur at any period after post compaction state due to seasonal variation or any other external factors. To address this drying phenomena in terms of volumetric property, I am here to discuss about the development of soil shrinkage curve, and to develop this soil shrinkage curve, how digital image analysis process can be used. So before getting into the experimental procedure, I'd like to give a brief, a small introduction. So in the left side, I have a graph about the variation of water content with respect to variation of suction potential. On the right side, it is a variation of void ratio and with respect to moisture ratio. So as you can see from the graph, suction potential, it is a negative pressure which is existing in a soil phase system. Usually a compacted soil which is above the water table will have three phases. One is solid phase, water and air interface. So in this in the soil, water and air interface, suction potential will exist. So the relationship between water content and suction is such that water content, with a decrease in water content, suction potential is going to increase, and sometimes it contributes to the increase in the geotechnical properties or the mechanical properties of soil. Whereas during the drying process, where suction increase happens, the void ratio is going to decrease. So there is a correlation between the volume of void change and the suction potential. As you can see, this soil suction curve, shrinkage curve, there are four phases I have mentioned: structural shrinkage, proportional, residual, and zero shrinkage. Usually, geotechnical engineers, we are interested with obtaining the shrinkage limit value, but this study I've determined the entire shrinkage process into a curve, represented into a curve, and this has been segregated into different phases. So with the segregation of these different phases of shrinkage, the pore size distribution can be indirectly, or it can be considered as a preliminary study. Whereas in elaborated research works considering the microstructural analysis of soil, mercury intrusion porosimetry study, FTIR study, SEM analysis, these are all carried out, which is quite sophisticated setups. But this development of soil shrinkage curve with a proposed method, it is very easy to give a basic understanding about the pore size distribution in the soil system. So usually this generation of soil shrinkage curve requires two parameters. One is the variation of water content, and another is the variation of void change or the volume change of the soil with respect to water content. The determination of water content variation is very easy, where it can be computed from the mass reduction with respect to time, or with respect to drying phase. What is the mass change? From the mass change, water content can be determined, but the determination of volume change is quite complicated. Usually we go for this immersion technique, where Archimedes principle is applied, or direct use of vernier calipers for determining the dimensions of the soil specimen. So that is a direct or contact measurement method, and in this there are high chances of sample disturbance, and the values are not that reliable. Whereas certain sophisticated advancements over this direct measurement is the use of sensors, digital image analysis, or photogrammetric techniques. So this is the testing procedure what I have followed. A low plasticity soil has been taken, and it is prepared into a slurry condition, and on the same slurry soil was placed into the shrinkage disc, and the weight measurement was taken continuously during the entire drying process. Similarly, the images were captured using a digital image with a 12 megapixel, and the determined points, the variation of water content and the volume change was plotted into the fitting parameters. So there are two fitting models I have selected. One is proposed by Fredland, and another one is Peng and Horn model to generate the soil shrinkage curve. Usually this soil shrinkage curve, as I have shown earlier, it has got 4 phases, but certain models they have their own limitation where all the shrinkage phases are not represented with the experimental data. So among the literature, from the literature review, I have selected these two models, and of this, Peng and Horn model seems to give the complete shrinkage curve characterization with using a single mathematical model. And simultaneously, I have determined the suction potential of the soil sample also. So for that, I have used another indirect measurement method where dew point potentiometer was used, and similarly, the experimental data were fitted into the mathematical models proposed by Fredland and Zing model, as well as Van Gunisten model. So this is the digital image process that was carried out. So this involves very simple steps. The captured images were imported into the ImageJ software. There are so many other softwares also available. So I have selected this ImageJ software, and in this the first step is to convert the image into a grayscale image, where the image is converted into black and white. And next one is the image segmentation. So this is called thresholding process. In the thresholding process, the threshold limit is set to convert the image into a separate foreground and background. So this threshold limit plays a major role in the reliability of this image analysis process. So by performing this process on soil samples, I have determined the volume, and the volume was converted into the void ratio, and the shrinkage curve plot was obtained for my soil sample. So for the same experimental data was fit into the mathematical model which I already mentioned earlier. So this is the soil shrinkage curve I have obtained, and from the curve, uh, uh, all soils do not possess all the 4 shrinkage zones. So this soil possesses only the proportional or the normal shrinkage zone, as well as the residual and zero shrinkage zone. This soil is lacking of structural shrinkage phase. So this gives an overall idea about the process distribution of this soil. And similarly, the sensitivity analysis of the fitting parameters and their influence on the shrinkage curve was also studied, and the results obtained from the study is in coherence with the literature reviews. And another major determination from this soil shrinkage curve is the general air entry region. That means the point where the air starts to enter into the soil phase system, and thus the volume change is induced. So here from the graph, the general air entry value is obtained to be 36%, and this value seems to be always close to the plastic limit of the soil. And for my samples also, I have got the similar results, and this is in coherence with the findings of Liu et al. In 2015. So this is the conclusion. Usually in laboratory, by following this digital image analysis, isotropic shrinkage condition is assumed, and the test procedures have been happened. But in field condition, like in wetting and drying cycles, which durability analysis we used to carry out. So in that phases, the shrinkage is not isotropic, and it is usually anisotropic. Hence, further enhancement in the sample sizes, in the consideration of geometry factor into the fitting models can be carried out. Similarly, image analysis process has been found to be very easy. Continuous measurement of data is available, and quantitative measurement of soil volume change is also possible with this method. This can be incorporated for analysis of volume change for bigger size samples like UCS samples, triaxial samples, where durability analysis is carried out. This procedure can be adopted, and there are so many other softwares are also available which can be utilized for the study. Thank you.
Sharanya, I
Thank
have
you. Yeah, go on, sir.
volume shrinkage is a 3D phenomena, right?
Yes, sir.
And you are doing 2D measurements.
Yes, sir.
So how do you correlate that? Because you are measuring only the
Rate
from the
and
top, right?
Yep. So in this study, as it is a preliminary study to verify, I've only gone with this radial analysis because I've tested the sample as a slurry also, and it is in a steel shrinkage dish. That shrinkage dish I have placed in the soil sample. So in case of slurry samples, to go for 3D analysis is tedious. But in case of compacted soil samples, we can place them directly on the weighing balance, and the camera positions can be fixed such that we can determine the height variation of the sample also, sir.
So you'll get average height.
Yes, sir.
Otherwise, you can try stereoscopy with 2 cameras.
Yes, sir. So this is the simplest procedure which can be followed for where sophisticated setups cannot be arranged.
Very
This
good.
seems to-
Thank you. That's all. Thank you.
Thank you, sir.
Thank you. Any question? Any addition? Another question? No. Okay.
Yes,
let us
one
move.
question I asked that can you measure soiling pressure with this volume change measurement?
Swelling pressure, we cannot quantify it, sir. Only the swelling, the volumetric strain in terms of swelling potential, we can study them.
But how can it be done without application of any surcharge?
Pardon?
It is meaningless because whenever we measure the soiling, we actually bring effect of certain surcharge.
Surcharge, yes, sir.
Yes. So are you measuring it against some surcharge or no?
There are studies which have proven with the surcharge application also. In my study, I have not presented about the effect of surcharge load, sir.
Okay.
Okay. Thank you, Sharanya, for your presentation. Let us move to the next presentation, theme paper number 13, the approach for geotechnical site characterization of brownfield site of a steel plant by Mr. Manoj De and Shruvanshu Kumar R.
Good evening, sir.
Yeah, Mr. Manoj.
Good evening, sir. This is Manas De, and my co-author is Subhranshu Raut. We are from Tata Consulting Engineers, and we present a case study on application of triad approach for characterization of brownfield site in a steel plant.
Yeah, go on. Please start your presentation.
Sir, can you see my presentation? I presented it.
No, you just have to present now. Go on to the screen, let's say menu of a present now.
Yeah, it's visible now.
So this is the outline of my presentation. We go with a brief introduction, review of the references, then methodology, results, and conclusion. And the triad approach has been developed by the US Environment Protection Agency for characterization in general of hazardous sites, and it has 3 elements of systematic project planning, dynamic work strategies, and real-time measurement. Now, in a context of geotechnical characterization, the conceptual site model that is developed will involve the structure layout on the site, then the foundation requirements that are required for those structures, the site topography, the presence of existing features, geological information, and the information on existing services. The important aspects of geotechnical characterization of a project site would include reduction in the design and construction hazards, delays and cost overruns, graphical representation of the investigation data, develop an accurate conceptual site model, quantify the soil behavior, and the cost of investigation is justified by the benefits of risk mitigation and better performance of the foundations. So these are the steps involved in the geotechnical site characterization. They are preliminary desk study, reconnaissance surveys, preliminary and detailed investigations. And the sources of information that are used for this characterization include the geological records, historical data if it is present, construction records from previous projects, and finally the ground investigation data that is carried out for the project. Now, the important points to be noted in a geotechnical characterization are that the volume of sample collected during the investigation process is insignificant compared to the actual volume that is present at site. Then there would be effects of material heterogeneity. The relation between the actual test done and the quality of data that is collected from site is sometimes not very clear. The investigation is also carried out in the early stage before the site layout of the project is frozen, and there may be some constraints due to accessibility of site, especially in brownfield conditions, and the budget constraints. So the way that we developed the application of triad concept was that we took the advantage of the mapping the unknown subsurface, natural and man-made features at the brownfield site. A brownfield site is one which has been previously used for construction, and then the previous function has been demolished. And then the risk mitigation through actual site data collection use of that in engineering. So this shows the layout of the project site. We were designing for a process plant, and we were given 2 land parcels, though the plant is a single plant, but because of paucity of land at one place, we were given 2 parcels, one of 38 acres, the main plant, and the secondary product area of 7 acres, and they were separated by 500 kilometers connected by utility lines. The conceptual site model that was developed in the systematic project planning stage consisted of the process plant layout, the foundation engineering data that specified the depth, size, and settlement sensitivity of the various foundations, which you can see in table 1 for some of the main process units which has been plotted. This was specified by the designer. So based on this, we prepared the initial geotechnical investigation plan with 32 boreholes, 28 in the main plant area and 4 in the secondary product area. SPT was conducted at every 1.5 meters. Boreholes were 30 meters deep for 6 boreholes and 3 meter into mica schist rock, where the core recovery would exceed 50%. 5 plate load tests were conducted, and various laboratory tests of grain size, Atterberg limits, specific gravity, shear tests, and rock crushing strength to determine the design parameters for foundation bearing capacity. So using this data, we generated the soil profile for the entire site. So there are 5, in general, there are 5 layers identified, and the bearing capacity of each layer for isolated footings and raft footings at various depths were calculated. Now the next stage of this, so based on this conceptual site model, now we developed a dynamic work plan. What was found was that if we compare the table 1 values of bearing pressures required at the expected foundation depths with the foundation pressure that was available at those depths, we could find that the actual bearing capacity available was inadequate. So the instead of changing the entire foundation design, what we had adopted in the revised design scenario was that we would excavate to the level of the bearing medium that would be able to bear that load, which was found to be stratum 3A, and used concrete fill from the top of that excavation till the bottom of the design, bottom of foundation. So we were not changing any of the foundation designs. We were using the intervening space to fill it up with lean concrete, and that would provide the resting bearing support for the foundations. So now that we have changed the execution plan, to supplement this decision, we needed to do more investigation. So more investigation was carried out to map the boundary of stratum 3A, which was critical for supporting the foundation loads. So we have shown in one section only. Actually, we took many cross sections all along the plant, and this blue, light blue layer is the stratum 3A, which was the adequate layer for providing support to the foundations. So all these were plotted, for the entire site, and we can see the various strata that were plotted, and stratum 3A was determined to be the adequate stratum for locating the placing the foundation loads through the lean concrete fill. Now, the next stage was the real-time measurement strategy.
Mr. Manas, please conclude.
Yes, sir.
Because we are running short of time.
Yes, sir. Yes. So after we had decided this, we needed to devise simple tests to be carried out at site to determine that we had reached stratum 3A. So the site tests that were identified were visual identification, use of a geological hammer to measure the impression, and resistance of the stratum 3A to mechanical excavation. These were initially benchmarked, and those values were used to determine the approach to that we had accessed stratum 3A. So with this process, we were able to use the collected data for the entire site and provide the proper foundations for the various structures which had very heavy loads of going up to 30 tons per square meter. These are some pictures from the site showing the soil investigation, plate load test, the excavation work, the various strata. We see that we have reached stratum 3 and we are covering with the lean concrete. And here we see the foundation placed on the concrete fill. So in conclusion, we can say that by applying the concepts of triad method for characterization of this ground, we could characterize the brownfield site by selecting suitable foundation stratum and match the foundation type and the load, and identify the correct stratum during the excavation with real-time decision making the use of the proper site data. Thank you, sir. Thank you, sir.
Yeah. So, any questions? I think, Jay, we can move to next presentation.
Yeah. I also. Thank you, Mr. Dev, for the presentation. We will move to the next paper, which is number 15, Effect of Palm Fibers on Lime Blended Sandy Clay by Athira T and Sini T.
Yes, sir.
Yeah, please stick to the time frame. We are running short of time because the AGM is scheduled shortly. So please,
Okay, sir.
let's say stick to the time. You all have a 6 minutes
Yes, sir.
time for presentation.
So can you see my slide?
Yes.
Okay, sir. Good evening. I'm Adira T of College of Engineering, Trivandrum from Kerala. My topic of presentation is Effect of Palm Fibers on Lime Blended Clay Sand. Let me give a brief introduction. Major challenges faced by geotechnical engineers are developing economically feasible and durable methods of ground improvement. Soil stabilization refers to any physical, chemical, or biological, or a combination of these methods to improve the soil properties in order to meet our requirement. Through soil stabilization, the unbound materials can be stabilized with cementitious materials such as cement, lime, fly ash, bitumen, or a combination of these. Many stabilizers have been used all over the world to improve the problematic soil in terms of its compressive strength. In this paper, we are using lime and palm fiber as the stabilizers. Now, scope of the study is to determine to improve the tensile resistance of soil along with the compressive strength, incorporating waste materials to improve the soil properties, and to study the effective arrangement of fiber in improving the strength of the soil. This is a brief of the literature review. Now going to the objectives. The main objective of this paper is to investigate the effectiveness of lime and palm fiber in improving the properties of the soil, to determine the optimum lime content, to determine the optimum dosage of palm fiber in random mix and horizontal mix, to compare the improvement in compressive strength of lime stabilized fiber reinforced soil in random mix and horizontal mix. For this study, the soil was collected from the Thonakil region of Trivandrum, district of Kerala, and the palm fiber was bought from a supplier. Now going on to the methodology. First of all, we have to determine the optimum lime content by varying the percentage of lime. That is, we have taken 0, 5, 10, 12 and 15 percentage of the lime and mixed with the soil and determined unconfined compressive strength. And we have and we'll determine the optimum lime content. And after determining the OLC, we'll keep this optimum lime content as constant and we will vary the palm fiber content. Here we are taking 0.1, 0.2, 0.3 and 0.4 percentages of fiber content and conducting unconfined compression test for determining the optimum fiber content. And here also we are mixing the fiber with the soil in two different arrangements. In first we are mixing the fiber randomly with the soil lime mix, and in the next arrangement we will be mixing the soil we will be mixing the fiber in layers. After each layer of soil we will give a layer of fiber. Now going on to the experimental studies, these are the basic properties of the soil determined. These are the properties of the palm fiber as provided by the supplier. Now going on to the results and discussions. First of all, different lime contents were taken and compaction test was conducted to determine the variation of maximum dry density as well as optimum moisture content. From the graph we can be seeing that as the percentage of the lime increases, the maximum dry density is found to be decreasing, whereas the optimum moisture content shows an increasing trend. Now, by getting the optimum moisture content, we are conducting the unconfined compression test for different dosages of lime. As we can see that up to 10%, the UCS shows an increase in value, but with further increase in the lime, it shows a decreasing trend. And also by comparing the different curing periods, we can see that maximum strength was obtained for the sample cured for 28 days. And here we get that 10% of the lime was obtained as optimum percentage. Now with 10% of lime as constant, we are varying the fiber content, that is 0.1, 0.2, 0.3 and 0.4, and we conduct the compaction test. From here we can see that as a percentage of the fiber increases, the maximum dry density shows a decreasing trend, whereas the optimum moisture content shows an increasing trend. Now with these OMC, we are conducting unconfined compression test for different percentages of fiber. In first case, we are mixing the fiber randomly with the soil lime mix, and we are conducting the UCS test. We can see that up to 0.3% it showed an increase, and after 0.3% it shows an decrease in the strength. By comparing the result was for 0-day and 7-day curing, we see that the 7-day cured sample shows an improvement much higher compared to the 0-day cured sample. And going on to the results for horizontal mix, we can see that up to 0.3% it showed an increase in the value, but for 0.4% it shows a decrease. And here also 7-day cured sample is better in improvement than the 0-day cured sample. Now, comparing the results of horizontal mix and random mix, we can see that the random mix sample shows much effective in improving the soil than the horizontal mix. This is for the peak strength. Now going on to the conclusions, with the addition of lime and fiber, optimum moisture content increases whereas maximum dry density decreases, which is due to the pozzolanic reaction between lime and clay. The compressive strength of soil increases with increase in lime up to 10%. After 10%, strength decreases with further increase in lime content. Hence, optimum lime content is obtained as 10%. With 10% lime as constant, effect of fiber reinforcement is studied by varying the fiber content and conducting unconfined compression test. With the addition of fiber, optimum moisture content increases, whereas maximum dry density decreases. As the palm fiber content increases, the compressor strength first increases, but after 0.3% it is found to decrease. The random mix of palm fiber increases the peak strength by 12 times the unreinforced soil. Whereas in the case of horizontal mix, the palm fiber increases the peak strength only by 11.36 times the unreinforced soil. By comparing the random mix and horizontal mix of palm fiber, randomly distributed fibers showed the improvement more effectively than the horizontal mix. These are the references. Thank you.
Thank you for the presentation. There is one
Thank you,
announcement
sir.
from the organizer. We have IGS as a AGM, annual general body meeting, which is scheduled at 6:30. So we need to stop this session right now over here. And whoever the left, I think paper number 16, 18 and 24 are there, which we will be able to take it tomorrow in the same session. Let's say tomorrow it will say December 18th. And theme number 1, the same will be taken at tomorrow. Yeah, Mr. Muthukumaran, do you want to add something over here?
Yeah, that is what we got the message from the organizer. Just the AGM is going to start. So since we are short of time, sort of closing by this with this paper, and the rest of the paper, 3 papers will be continuing in the tomorrow's session. So I request Professor Amit and Dr. Jay to conclude this session, please.
Jay, you want me to conclude?
Yes, sir. Please do that.
Okay. So,
sir, excuse me, sir. Tomorrow, at what session, sir? Which session we need to present, sir, tomorrow for the remaining paper?
Yeah, the same theme number 1.
At what time?
We will let you know, please. Just a minute, I'll inform you.
Theme number 1 is at 2 o'clock tomorrow, and same link.
Same link too.
Same link.
Yeah, same link too.
Okay. Okay. So we had a wonderful talk by Professor Mukherjee, who talked about the lime and husk formation, also fly ash and geotextile combination, how they can help in CBR changes, etc. And also the effect of molding water content on that. And also concluded that with the design of payment with respect to that, which was a very comprehensive study. And thanks to Professor Mukherjee for sharing all that knowledge. We had, I think, presentations in the contributed papers. In first by Dr. Akhila, she presented the impact of different constituents of soil by mixing them, and based on that, we had some basic characteristics and liquefaction potential assessment. And then Satyajit Roy presented from CSMRS some empirical correlations for permeability, and also compared those with constant tech test, and the applicability of correlations were verified, and 4 different sands they considered in that category. Then we had V.K. Jain, Mr. Vikas, who presented some soil characteristics for efflux bend of a barrage with the high plasticity clay, unique study indeed. And then we had Anju Mary, who had large data of soil collected from Kerala and used ANN to present some models. You can say develop a model and improve it. Then we had Dhana Teja, who had coir fiber and soil mixing, and conducted some compaction, CBR and UC test, and showed how this can impact the behavior as such. Then Annie J, who had focused on the study on curing period, very interesting work on lime treated organic soils. And organic soil can be really painful sometimes, and the study was up to 90 days. So there were some surprising results, and she also told that there is some continuing work on how to handle the issues. Then Dr. Natarajan had presented shear strength properties of 4 different marine sands at different densities and depths, And then Sharanya presented another work, some unique image analysis for shrinkage measurements in clay type soils. And last presentation, last but one, Manas Day, there was a triad method that was used for characterization of ground in Tata Consulting projects. And it's claimed to be giving much more information about the ground in a better way to help the project. And then last one, we had Athira, who presented some palm fibers and lime mixing with some shear strength characterizations, and that you can say how it can help improve the ground also in the long run. I hope some application to ground will be also studied at a later stage. So with that, we could conclude this today, and my apologies for all the delays that have happened. We will continue the presentations tomorrow, and I look forward to the remaining 3 presentations. So that's all from my side. Thank you. Jay, you want to add anything?
Yeah, thank you so much for your wonderful session. And though we have short of time, but the papers have been very well organized, and you have consolidated the session very well. And on behalf of the organizing committee, Sir Amit and Dr. Jay, for conducting this session very efficient manner. Thank you so much. Members, please can join for the AGM. Thank you. We'll meet tomorrow. Thank you.
Thank you, everyone.
Thank you so much.
Yeah.
Jay, you want to stay back?
We can discuss regarding this 2 paper selection.
Right. Right.
Yeah. But we have tomorrow 3 paper is pending from this list. So
okay,
these. So
yeah,
what I can do is we can discuss tomorrow. That's better.
Yeah, tomorrow we'll discuss.
Because I will be there in a co-chair in the same session. So
that's right.
I will be having all the things.